Hi there, welcome to the second tutorial for the mechanism design project. In the last tutorial we showed you how to create a pendulum model in Simulink and be able to cycle that through time and produce a pendulum motion as shown by running this simulation, and the resulting output is a massless beam with a 2 kilogram mass at the end swinging 20 centimeters away from the origin. What we're going to show you today is how you do a feedback loop. So in your mechanism design, when you're actually going to generate your mechanism for the car convertible roof, you'll be actually powering your mechanism through a motor. And the motor will have to use a feedback loop based on the speed at which that mechanism is running, because you'll be working up and down a motor profile. So this is a really quick short demo of just showing you how to take a sensor reading from your joint, using that to calculate a new force or torque on your system, feeding that back into the joint. And what we're actually going to do is just fix this beam in position. Okay, so we're going to do that by using our Trig identities and understanding that we know the resistive torque is going to be based on the point mass, the distance of the beam, the angle, the cos angle, and the work we're doing against gravity. So what we need to do is actually calculate the resistive torque we need to prevent this beam from moving. To do this, we are going to use our mechanism blocks again, our templates of blocks. We're going to use the function. So we're going to create a function that uses the current displacement or position of the beam, and from that we can calculate the torque we need to keep it in that position. So we've just copied and pasted that across. What we need to do is then just join that and take the signal, basically take that position, find out what the position it is at any one point in time. And as you expand this block, you can see it already has a function, a default function in it. What we're going to do is actually edit that function for our needs. The first thing we need to do is we need the gravity. So we need to resist this gravity. So we need that value. Okay, so copy and paste that. What we're going to have, it's going to be gravity times the distance of the beam. So 0.2, remember it's in SI units. Your point mass of 2. And we are going to also then have to know the angle at which that mass is at. So we're going to use that cos, and we're going to use the variable u, which is the input to that function. Okay, so we're taking u, and u is actually going to be our current position. Okay, so we've got mass, gravity, length, and cos u. So we just have to click apply and OK that. So that's going to be our equation. Okay, and what we can actually do is, in our function, even just give it the equation so we remember what we're trying to achieve. So mgl L cos u. Okay. So it's always good to just always update these indexes. And for when you do your A3 page for the submission, we'd like to have all these all annotated so we understand what each of the blocks are trying to achieve. Now what we need to do is actually feed that back into the joint and give that joint the torque that that's calculating to resist the force produced by this beam. So what we need to do is actually, if you double click on the joint, what we can do is give it actuation, which is give it an input of torque. Okay? And what we're going to do is say provided by an input, and we'll click apply. And that gives us a new input to our revolute joint. Now what we just need to do is join those two together. And what we've done actually is take basically a signal from a physical system, and we've turned it into a Simulink sensor, which you could imagine is an electronic signal. What we want to do is take that signal and return it into an actual physical force. So what we're going to do is just take our S to PS converter, the opposite way around. What we can do is right click and flip this block, and we just need to then click and join those blocks together, and click and join that back to our torque. So as you can see, it's quite interpretive, it's quite easy to understand. You're taking a displacement, you're then performing a calculation on that displacement, and we're then feeding that back into the system to provide us our new torque that's going to be working against the beam. Okay, so if we just need to double check it's worked. So if we click run, and now watch our system, as you can see, actually nothing's happening. And that's the case that we're calculating the torque, the resistive torque needed to maintain the position of this pendulum. And that is, in essence, that's all we need to do for this tutorial. It's to show you how to take a signal from one of your joints and feed it back into the joint to give you the torque you need to keep it in position. Thank you very much.